This video is about comparing rates. We compare rates often in the real world. For example, when we answer the following questions, we're probably comparing two different rates. Which store has the better value? Which runner is going faster? Of these two lemonade recipes, which one is sweeter? In this video, we're going to look at comparing which store has the better value. Bob loves to incorporate fancy spices into his burger recipes. He finds two stores that carry the spice he needs. Store A sells 4 ounces of the spice for $5.25. Store B sells 7 ounces for $10. Which store has the better price for the spice Bob needs? We're going to be focusing on finding a common value and then comparing. I'll look at 4 different common values. In each case, I'll use a table to organize my thinking. First, we're going to compare the same number of ounces. So I need to set up 2 separate ratio tables because I have 2 separate rates. So I have store A and I have store B. In both cases, I'm going to be looking at ounces and dollars, and I fill in from the problem. 4 ounces for $5.25, 7 ounces for $10. I can pick the same number of ounces, so I want the same value in the second cell right here. The easiest for me is the least common multiple. The least common multiple between 4 and 7 is 28. I can multiply by 7 in the first table or multiply by 4 in the second table. And because I'm using multiplicative reasoning, if I multiplied by 7 for ounces, I'll also multiply by 7 for dollars. Similarly, in the second table, we'll multiply by 4. So I'll do my computations and fill in the values. Now that my table is complete, I want to compare the 36.75 and the 40 and decide which one gives me the better value. In this case, if I go to the store and buy 28 ounces, I'd be happier if I spent less money. So I'm looking for the lesser value, which will be 36.75. So store A has the same value, has the better value. Now instead of comparing the same number of ounces, I'm going to compare the same number of dollars. I want to have matching amounts of dollars. To me, the easiest thing would be to multiply by 10 here and to multiply by 5 25 on the right. Once I fill in my values, I can compare. So I say if I spent $52.50 on spices, would I rather get 40 ounces of spices or would I rather get 36 ounces of the spice? Well, for the same amount of money, I'd rather get more spice. So store A has the better value. In this case, I was looking for the greater value, more spice. So I'd rather get more spice for the same amount of money. Above, remember, I wanted to spend less money to get the same amount of spice. So we can't just rely on our calculated value being greater than or less than. We have to stop and think about the context. Another strategy, same idea, different common value, is to go through 1. And here we're working with unit rates when we choose our common value to be 1. If we wanted to know dollars per ounce, we're really saying dollars per 1 ounce, right here. And I go through the same process. To get from 4 to 1, I'm going to divide by 4. To get from 7 to 1, I'm going to divide by 7. So let's go ahead and do these computations. Now it's time to compare. Which one shall we choose? Well, if this is per 1 ounce, I'd rather pay less. I'd rather pay $1.31 for 1 ounce than pay $1.40 for 1 ounce. Here we chose 1 ounce as our common value, but we could have chosen $1 if we did ounces per dollar. We're doing ounces per $1. 1 is our common value, our unit rate here, and we can see we had to divide by 525 and divide by 10, so we can fill in our numbers on our table. So here we're comparing 76 hundredths and 7 tenths, and for every dollar that I pay, I would like to get more ounces of my spice. So that makes store A the better deal, more ounces for every dollar. Notice with these unit rates, I was essentially comparing fractions. So I was essentially comparing these two fractions where my units were ounces per dollar.